Hello, everybody. This is John Ross, and I'm here to continue doing a little bit of some place value exploration with you as we continue to explore our base 10 system. And the standard that we will be focusing on today is 5.NSBT.1, and our learning objective reads as I can explain that a digit in one place represents 10 times what the same digit represents in the place to its right, and represents 1/10 times what the same digit represents in the place to its left. For our activator, we have an image here that contains 4 different types of base 10 blocks. So I'm going to want you to take about 30 seconds to just silently analyze this image, make any sort of observations that you can, and also think about the value that each of those base 10 blocks actually represents. So 30 seconds begins now. All right, 30 seconds has come to an end. So at this time, I'm going to encourage you to pause the video if you have a sibling or parent or guardian who is with you so that you can share with them the observations that you made related to those various base 10 blocks, because it is important that we practice using the mathematical language so that we are more familiar with that language and more comfortable with it. All right, so hopefully you have had some time to share your own thoughts related to that image, and now I will share some of mine with you. The first thing that I'd like to share is the name of each of those blocks. Here we have a unit, and here we have a rod, here we have a flat, and here we have a cube. And so I know that the value of a unit can be represented by the whole number 1. I know that the value of a rod can be represented by the whole number 10, and that is in part because it takes 10 of those single units to make a rod itself. I also know that a flat has a value of 100 because a flat can be built out of either 100 single units, or it can be built out of 10 rods. And a 10 rod has a value of 10, so if I have 10 of them, that's 10 times 10 equals 100. I also know that a cube represents the whole number 1,000. And I know that to be true because there are 10 flats that can be used to make this cube, and a flat has a value of 100, so 100 times 10 gives me 1,000. I also know that each of these blocks, as I move to the left, has a value that is 10 times greater than the block to its right. And that is because, again, here in this case, we have a rod that is built out of 10 units. Here I have a flat that is built out of 10 rods. And here I have a cube that is built out of 10 flats. I also know that as I move to the right, that each block to the right has a value that is 1/10 of the block to the left, because this is one piece out of 10, this flat, that are needed to make a cube. So the flat has a value that is 1/10 of a cube. I know that a rod has a value that is 1/10 of a flat because it takes 10 rods to make a flat. And then finally, I know that a unit has a value that is 1/10 of a rod because it takes a total of 10 units to make that rod. So at this point, we're going to do a little bit of some I do, where I'm going to walk you through how we can use a place value map to just gain a little bit better of understanding of the value of various digits. So here we're working with the number 222. So I'm going to fill in this top row right here with the appropriate digit. So I have 200s as represented here with this 2. I have 2 tens, and then I have 2 ones. Now, if I wanted to represent those with blocks, or in this case with drawings, I would draw a flat, actually 2 of them, because I have 200s. So that would look a little something like this. I can draw 2 large squares to represent 2 flats. For my 2 tens, I can either draw 2 straight lines or 2 skinny rectangles. And then finally, for 2 ones, I could draw 2 circles or 2 teeny tiny little squares to represent my 2 ones. And so here I have my number, which is pretty much written in standard form, 222. I have my number represented in its model form, or its drawing form, if you will. And now what I want to do is represent the value of those digits in this bottom row here. And so the value of this 2 is 200, because I have 2 flats or 2 hundreds. The value of this 2 here is 2 tens, which is 20. And then finally, the value of my 2 ones, or my 2 units, is simply 2. Now, when I look at this bottom row, it makes me think of another form that we can use to represent a number. So here we kind of have standard form, definitely right here. Here we have our model form in drawing form, if you will. And then if I put a plus sign in between the 200 and the 20, and the 20 and the 2, I can basically represent that number in its expanded form in this bottom row as well. So remember, our learning objective was to basically note that a digit to the left, so if I'm focusing on this 2 here in the tens place, the digit to the left that is the same digit, so we got 2 in my tens place and 2 in my hundreds place, the digit to the left has a value that is 10 times greater than the digit to the right. So again, if I'm focusing on this 2 in my tens place, the digit to the right of it has a value that is 1/10 of the value of that 2 in the tens place. Because basically it would take 2 times 10 to get us our 20, and our 20 times 10 to get us to 200. So another I do here. At this point, we're just moving along, slightly larger number, 333. We're going to place those digits in the appropriate column. And so I've got a 3 in my hundreds place, a 3 in my tens place, and a 3 in my ones place. If I want to represent that in drawing form, I could use 3 large squares to represent that we have 3 hundreds or 3 flats. I can then do 3 skinny rectangles or 3 straight lines to represent that I have 3 tens, and then finally 3 single units to represent that I have 3 ones. The value of the digit in the hundreds place tells us that that digit is worth 300. And then the value of the digit in the tens place is 30. And the value of the digit in the ones place is 3. And again, so now I have kind of my number in standard form, my number in model form, and I can place a plus sign between the value of each digit to also represent that number in a version of expanded form. So 300 plus 30 plus 3 is kind of this number decomposed into 300s, 310s, and 3 1s. And if I were to compose them or put them together, I would end up with my number in standard form, 333. All right, so at this time, we're going to be looking specifically at patterns of sorts. As we complete these next few problems, we should note that each of these problems here has a same factor. Each of these problems has the factor of 10, but what's different about these problems is that the other factor is getting larger as we move down from problem to problem. So here we have 7, 70, 700, 7,000, 70,000, 700,000. And so if I were to multiply 7 times 10, or say basically 7 groups of 10, that would give me 70. If I were to say 70 times 10, or 70 groups of 10, that would give me a total of 700. If I were to say 700 times 10, or 700 groups of 10, that would give me 7,000. If I were to say 7,000 times 10, that would give me 70,000. So if I were to say 70,000 times 10, that would give me 700,000. And finally, 700,000 times 10 gives me 7 million. And so basically what I'm doing is I'm highlighting here that if I multiply a nice round number such as 7, 70, 700, 7,000, I'm by 10. If I multiply that number by 10, I am able to identify a number that has a value that is 10 times the initial factor. Now, yesterday we worked also with identifying numbers that have a value that is 1/10 of a given number. So here we have 70 times 1/10. If I multiply 70 times 1/10, I will get 7. If I multiply 700 times 1/10, I get 70. 7,000 times 1/10, I get 700. 70,000 times 1/10, I get 7,000. 700,000 times 1/10, I get 70,000. And 7 million times 1/10, I get 700,000. And so basically the pattern that I note here is that as I multiply my first factor by 1/10, I'm essentially moving my decimal over one place to the left. So here would be a decimal, and I would move it over here to make that 7. And if I'm working with 700, I'm moving that decimal over one place to make that 70. In 7,000, move that decimal over one place for 700, and so on and so forth. Now this may, for some of us who are perhaps a little bit rusty with our multiplication of fractions, prove a little bit troublesome. And so I do want to show you that another way to think about multiplying a whole number by 1/10 is to actually think of dividing that number by 10 as shown here. So if I were to say 70 divided by 10, I get 7. 700 divided by 10, I get 70. 7,000 divided by 10 is 700. 70,000 divided by 10, I get 7,000. 700,000 divided by 10, 70,000. 7 million divided by 10 is 700,000. And so that's just an alternate view that one can take as far as multiplying a whole number by 1/10. We can view it as dividing that whole number by 10 because we are able to get the same value, since multiplication and division are inverse operations. So now we have another I do. We're going to be kind of analyzing this number here. That number is 4,962. Let's note that the 6 is underlined. We are now bringing into play 3 additional numbers that are all comprised of the same digits as are found in 4,962. Those digits have just been scrambled. And so our first question is, which of these 3 numbers here, has a 6 that has a value that is 10 times greater than the 6 in 4,962? So I want you to take just a few moments and think if you can determine which of these numbers, and they all have 6s, but which of those numbers has a 6 that has a value that is 10 times greater than the 6 in the tens place. All right, hopefully you have identified that number that has a 6 that is 10 times greater than the 6 in 4,962. And perhaps you've shared that with your sibling, parent, or guardian. So the correct answer, my friends, would be 2,694. And I know that that is the correct answer because here we have 6 in the tens place. And if that is 6 tens, and I want to know which of these numbers has a 6 that is 10 times greater, well, 60 times 10, friends, gets me 600. And so the only number out of these 3 that has a 6 in the hundreds place is 2,694. Our next question is, which number has a 6 that has a value that is 1/10 the value of the 6 in 4,962? So take a few moments and see if you can identify which of these 3 numbers has a 6 that has a value that is 1/10 of the 6 found in 4,962. All right, hopefully you have identified that number. Perhaps you've shared it with someone who is with you. And the correct answer is 9,462. And again, I know that to be true because this 6 is 6 tens, or 60, right? And so what is 1/10 of 60? 1/10, one part out of 10 that can be used to make 60, is 6 ones. And again, I can kind of flip that and reverse that and say that this 6 here is 10 times greater than the 6 in the ones place here. And we have another problem similar to what we just did. We have 382,794. Now I want us to, we're going to basically be looking at these numbers to answer the next couple questions. The first one reads as, which number has an 8 that has a value that is 10 times greater than the 8 in 382,794? So this 8 is used to represent 80,000. So we want to know which of these numbers has an 8 that is 10 times greater than 80,000. Take a few moments to see if you can identify which of those 3 numbers answers this question. All right, hopefully you have identified that number, and the correct answer is 874,923. And that is the correct answer because 10 times 80,000 gets me 800,000. So of these three numbers, the only number that has an 8 in the hundred thousands place is this first one. And finally, we have which number has an 8 that has a value that is 1/10 the value of the 8 in 382,794. 1/10 of basically 80,000. That's what we are looking for. Which of these numbers has an 8 that represents a value that is 1/10 of 80,000? Okay, hopefully you have found that answer, shared it perhaps with a fellow individual in your home. And the correct answer is 498,239. And I know that is the correct answer because 1/10 of 80,000 is 8,000. Because if I were to multiply 8 times 10, I would get 80,000. Or if I were to divide 80,000 by 10, I would end up with 8,000. Similarly, if I were to multiply 80,000 times 1/10, I would get 8,000 as well. And so I think we've got just this last one here, 58,419. The 4 is underlined, so we're going to be focusing on the value of the 4. We've got numbers that contain the same digits as found in 58,419. Those digits have been scrambled. So now I want to know which number has a 4 that has a value that is 10 times greater than the 4 in 58,419. Again, let's take a few moments to see if you can identify that number. All right, so which of these three numbers has a 4 that has a value that is 10 times greater than 4? This 4, and this 4 represents 400, so 400 times 10 gives me 4,000. So my correct answer is 94,185. And then I have this final question here. Which number has a 4 that is 1/10 the value of the 4 in 58,419? So again, we're looking to determine which of these numbers has a value that is 1/10 of the 4 in 58,419. All right, so we know that this 4 is in the hundredths place, so 400 times 1/10 gives me 40, or 400 divided by 10 gives me 40. And so as a consequence, I know that my 4 should be in the tens place, and that this number here, 15,948, is the only number that has 4 in the tens place. So that is our correct answer. At this time, we're going to go ahead and move into our independent practice, which can be found in Schoology. Thank you for joining us, and please don't hesitate to reach out to your classroom teacher if you have any questions.